All right. Hi, guys. Mrs. Townsley here. We are working on our 5-a-day, and we do have Tuesday, and this is for week 3. So it's Tuesday for week 3. All right. Take a look at the first one. It says you have 30 miles in 5 hours. Okay. This is the problem, and they want to know the rate. Now, the rate is just how it is. It is what it is. It's exactly what they tell us. It's 30 to 5. It's 30 to 5. Or 30 to 5. You can write it any way you want. You can write it with a colon, the word to, or a division bar. Now, the unit rate is a little different. The unit rate means you're looking to get to 1. So think unit. Unit means 1, and you want to get to 1. They want to know what 1 is worth. Okay, so in this case, it's 30 miles in 5 hours. So they want to know what 1 hour would then be. How far would you go in 1 hour? And to get to 1, you want to go ahead and use division, because anytime you get to division, it'll break it down into that 1 unit, that 1 component. So it's 30 divided by 5. So you take the first one divided by the second one. 30 divided by 5 is 6. So it's 6 to 1. 6 miles, 1 hour. Okay, good job. Moving on, number 2 says fraction. And they want you to take a look at this fraction right here that's in this grid. Okay, and this grid is a 10 by 10, which equals 100. Okay, and they want you to look at the part that's shaded versus the whole. So the part that's shaded is 10, and the whole, or the total, would then be 100. Now you could also see it in another way where maybe you're just looking at this 1 bar versus the total 10 bars. So you could look at it like that as well, and they both are correct. Okay? All right, now the decimal is right there. There's the decimal. So even if you're stuck, you know you need a decimal, which is that dot. Now you could look at it like 0.10 or 0.1. Okay? Either way, it's fine. This is 10 hundredths, or this is 1/10. Both show this over here on this side because you have 10 parts out of 100, or you have 1 bar out of 10. Okay? And that's the decimal representation of it. Okay, now the ratio is just like the fraction. It could be 10 over 100, or you could write it 10 to 100, or 10 to 100. You could write it 3 different ways. Okay, and the percents are always out of 100. Percent per 100. Okay, so what is per 100? It's 10 per 100, so it's 10%. Okay? All right, number 3 says 10 is 20% of what? And we're just going to go ahead and fill in this proportion. Okay, we're going to go ahead and fill in this proportion. We're not going to solve for it right now. We're just going to fill these in. So if you look on this side, it says percent. So you want to look up here and you want to find the percent, and they tell you that by that percent sign, that 20 needs to go there. Okay? Now 10 is, you have to decide, is that your part or your whole? Well, think. 10 is something of what? So what would make sense? 10 is, would that be your part or your whole? It would be your part. So your part goes here. Of what? Of what the total is, we just don't know. So if we don't know something in math, we just throw a variable in there. It doesn't mean we just leave it blank. We just throw a variable in there because we just don't know what it is yet. Okay? All right, good job. Moving on. Here's number 4. All right, 4 says Maria has twice as many, and I'm going to circle that, twice as many crayons as Corinne. Write in an algebraic expression, so we know an expression is not an equal sign, not an equal sign, okay, to represent the number of crayons that Maria has. Okay, so Maria has twice as many crayons as Corinne. So when you think of the word twice, you think of 2, right? Twice as many shoes, twice as many clothes, twice as 2. And we don't know Maria has twice as many crayons as Corinne. Write an algebraic expression represent the number of crayons that Maria has. She has twice as many, 2n. All right, the next one is a table. And X and Y are always in this relationship, all right? They always have this relationship going on. All right, and what it is, this is the key to the relationship. This is their key to the relationship. Y equals X minus 3, all right? That's how they make the relationship work. All right, so let's see if this becomes true. If X is 10, so instead of this X being X, they're saying, oh, by the way, it's 10. Okay, would Y be 7? Well, if X is 10, 10 minus 3 is 7. Yes, that becomes true. I agree. Now, what if X is 9? So now X is 9. And I know that because they told me. They told me X is 9. What is Y? Well, I don't know. But 9 minus 3 would give me 6. So I know 6 would work. Okay? Do it again. Here's 8. They give me X is 8. So now X is 8. 8 minus 3 is 5. Y is 5. This is the key to their relationship right here. Y equals X minus 3. Okay? We're not going to worry about putting anything extra in right now, but we are going to worry about graphing this. So if you want to start at this point, which is your origin, which is 0, you want to look at your X first. So you want to go over. So X always goes right here. X always goes on your horizontal or your left and right. Okay? So go here first. Start at 0, go over 10, and then up, how many? We're going up 7. All right, you put a dot there. We did that. Okay, so that one's finished. Your next one, your next two coordinates are 9 and 6. And sometimes they have these parentheses, which is fine, the common in the middle. Okay, you have 9 and 6. So you want to start at 0. You want to go over to 9, and then you want to go up 6. And you just put a dot there. Okay, we're done. Now your next two coordinates on your coordinate plane are 8 and 5. So you want to start at 0. You want to go over 8 and then up 5 and put a dot once again. Okay? And that's all they want you to do for that one right now. All right. Good job. I'll see you later. Hey, what's going on?
Hey, can you hear me?
Yeah.
I can.